Right now, along the equator in the Pacific Ocean, there is a patch of water warming up. Not by much. 2, maybe 3 degrees. You could swim in it and barely notice. But that little patch of warm water is about to change the weather on every continent on Earth. In one part of the world, rain that always comes just stops, and the ground cracks open in drought. Somewhere else, rivers that are usually calm rise up and flood whole towns. Fisheries collapse. Harvests fail. The planet's average temperature for the whole year ticks upward. All of it traced back to that one warm patch, in one ocean. We have a name for it, El Niño. You have probably heard it blamed for a strange winter or a brutal storm season, but El Niño is not a storm, and it is not a place. It is something stranger. It is a rhythm. Because here is the part that should stop you. A few years from now, that same patch of the Pacific will do the exact opposite. It will turn cold, and the whole pattern will run backwards. Warm, then cold, then warm again, over and over, for as long as we have kept records. The ocean is not just sitting there, it is oscillating. It has, for lack of a better word, a heartbeat. So where does the rhythm come from? How does a couple of degrees in one ocean reach across the whole planet? And why does it always swing back? To answer that, we have to build the machine that makes it, one piece at a time. Start with the normal state, the way the Pacific usually behaves. Along the equator, steady winds blow from east to west. These are the trade winds, and they are the engine of the whole system. As they blow across thousands of miles of ocean, they drag the warm surface water along with them and pile it up in the west, near Indonesia and Australia. So the western Pacific becomes a huge reservoir of warm water. We call it the warm pool. The sea there actually sits a little higher, and the warm layer runs deep. Now, if warm water is being pushed to the west, something has to replace it in the east, and it does. Cold water from far below rises up along the coast of South America to fill the gap. This is upwelling, and it makes the eastern Pacific cool and rich with nutrients, which is why some of the world's biggest fisheries sit right there. So the ocean takes on a lopsided shape, warm and deep in the west, cool and shallow in the east, and the air above it feels that difference. Over the warm western pool, the air is hot and wet, so it rises and it rains. Over the cool eastern water, the air sinks, dry and clear. The rising air in the west flows east up high, sinks in the east, and returns along the surface as those same trade winds. The giant loop of air sitting over the equator. It has a name too, the Walker circulation. Hold on to that picture. Winds pushing water, water shaping the air driving the winds. Every part is leaning on every other part. That is not a coincidence. That is the whole story. Look closer at that last sentence, because it hides the most important idea in this entire system. The winds move the water, but the water shapes the air that drives the winds, which means the system feeds back on itself. Let me make it concrete. Suppose the trade winds get a little stronger for a moment. Stronger winds push more warm water west and pull more cold water up in the east, so the eastern Pacific gets even colder. Now the difference in temperature across the ocean is bigger than before. And a bigger temperature difference makes the whole air loop work harder, which makes the trade winds blow. You guessed it, even stronger. Stronger winds, colder east, bigger difference, stronger winds again. The system is pushing itself. A nudge in one direction makes the next push bigger. This is a positive feedback loop, and a scientist named Bjerknes worked it out back in the 1960s. Positive feedback is a powerful thing, but it is also a dangerous one, because it does not know how to stop. A loop that amplifies itself will run away in whichever direction it gets pushed. So the obvious question is, what happens if it gets pushed the other way? What if, instead of getting stronger, the trade winds one day go slack? That is El Niño. It often starts with something small. The trade winds ease off, just a little. But you already know this system does not do small. With the winds weaker, they can no longer hold all that warm water piled up in the west. So it starts to slosh back east, spreading across the Pacific like water tilting in a bathtub. The Eastern Ocean, normally cool, begins to warm. And now run Bjerknes backwards. Warmer water in the east means a smaller temperature difference across the ocean. A smaller difference means the air loop weakens. A weaker loop means even lighter trade winds, which lets even more warm water slide east. The same feedback that held the normal pattern together now tears it apart and rebuilds it inside out. The warm pool, the rain, the whole engine, all of it shifts thousands of miles to the east. The rain that always fell over Indonesia now falls over the open Pacific, and the coast of South America, usually bone dry, gets drenched. That is the flip we started with. Not a storm that rolled in, but an entire ocean and its sky reorganizing themselves, because one loop got pushed the other way. Which brings us back to the real mystery. If this feedback amplifies whatever it is given, then once the Pacific tips warm, why does it not just stay warm forever? What pulls it back? Here is the answer, and it is the most beautiful part of the whole system. Everything we have talked about so far happens at the surface, but the real memory of this system is stored underneath, in the total amount of warm water sitting in the equatorial Pacific. Think of it as the ocean's savings account of heat. When an El Niño is in full swing, with all that warm water spread thin across the surface, something quiet is happening below. Along the equator, the ocean is slowly draining its heat away, toward the poles. The warm layer gets thinner everywhere on the equator. The savings account is being emptied. And this takes time, months. The draining does not peak when the El Niño peaks. It lags behind. That delay is everything. By the time the El Niño reaches its height, the equator has quietly run low on warm water. And a Pacific running low on heat cannot hold the warm state. The cold water below is closer to the surface than ever. The upwelling gets easier, and the system tips and starts sliding the other way. Toward cold, toward La Niña. And then the whole thing runs in reverse. La Niña slowly recharges the warm water back onto the equator, overshoots, and quietly sets up the next El Niño. So there it is, a feedback that amplifies, plus a delay before the system pushes back. And anytime you combine a strong feedback with a lag before it answers, you do not get something that settles down. You get something that swings. You get an oscillation. That is the heartbeat. Warm and cold, every 2 to 7 years, kept alive by heat, quietly moving up and down in an ocean you cannot see from the surface. Now for the part that touches your life. That warm patch does not stay a local story, because the atmosphere carries it. When the rain shifts thousands of miles east, it drags the jet streams, the fast rivers of wind that steer weather across the whole planet. And once you move those, the effects fan out along a web of links that scientists call teleconnections. One warm patch in the Pacific, and southern Africa dries out. The monsoon can falter over India. California gets storm after storm. The Atlantic hurricane season often goes quiet, and the planet's average temperature for the year nudges upward. The hottest years on record tend to be El Niño years, riding on top of the long warming trend, not instead of it, which makes El Niño one of the few things about next year's weather we can actually see coming, months ahead. And that is genuinely useful. Farmers, water managers, whole governments plan around the forecast. But here is where we stay honest. The Pacific is hardest to predict in the spring, a frustrating blind spot forecasters call the spring barrier. No two events are the same size or hit the same way. And how this heartbeat itself changes as the planet warms is still an open question, one of the active ones in the science right now. We can hear the rhythm. We are still learning to read exactly what it will do next. Step back and look at what this really is. A feedback loop that amplifies, a delay before the system answers back, and out of just those two ingredients, a rhythm that never quite repeats and never quite stops. Once you see that shape, you start seeing it everywhere. It is your heartbeat, a pulse driven by feedback and delay. It is predators and prey, rising and crashing in cycles across decades. It is the boom and bust of an economy, the same simple recipe playing out on a coral reef, in a bloodstream, and across an entire ocean. The Pacific is not misbehaving when it swings between warm and cold. It is doing exactly what a complex system does when you wire it up this way. It is keeping time. So the next time you hear that El Niño is coming, you will know it is not a visitor and not an accident. It is one more beat of a rhythm that has been running under the Pacific for as long as there has been a Pacific, a planet, quietly keeping its own time.